there, children. Gandalf the Graphing Wizard here talking to you about graphing absolute value functions. Now here's a question. How many quarters does it take to play the Lord of the Rings pinball game? None! It only takes tokens! Ha ha ha!
First thing we're going to talk about is an axis of symmetry. That's a line through a shape so that each side is a mirror image. When the shape is folded in half along the axis of symmetry, then the two halves match up. So here you can see our axis of symmetry along this dog's face is this vertical red line. The axis of symmetry for this absolute value function right here is going to be this vertical red line. Same thing here. The axis of symmetry for this parabola is going to be this vertical red line. It's going to cut the shape, the graph, in half so that the half on the left matches up perfectly with the half on the right. Now, a parent function is going to be the simplest function of a family of functions that preserves the definition or shape of the entire family. So what does that mean? Well, here, the most basic linear function you can make is y equals x, or f of x is equal to x. Okay, you're not doing anything to x, you're not multiplying it by 2, you're not adding anything, you're not dividing it by anything, it's just y equals x. F of x is equal to x. That's why it's the parent function. Here, the quadratic parent function is y equals x squared. It's the most basic quadratic function you can have. You're not doing anything to x squared. Here is that parent function. Parent function for a cubic function is y is equal to x cubed, or f of x is equal to x cubed. This is the parent cubic function. And then the parent absolute value function, which is what we're going to be dealing with today, is y equals the absolute value of x, or f of x is equal to the absolute value of x. This is what that parent function looks like. So now let's talk about absolute value functions. So here we have the vertex form of an absolute value function. We have y is equal to a times the absolute value of x minus h plus k. First, the x is your independent variable, the y is your dependent variable. Those are going to stay x and y. Now, these variables represent a specific constant that changes your parent function in a certain way. The a, the h, and the k are going to become constants, and they are going to, again, change your parent function in a specific way. First, the a value. If a is positive, you're going to have an upward facing v for your absolute value function. If a is negative, it's going to cause a reflection over the x-axis and make it a downward facing v. If a is a number that is greater than 1 or less than -1, you are going to have a vertical stretch, which means your graph is going to be a steeper v. If a is somewhere between -1 and 1, like a fraction or a decimal, then it's going to be a flatter v. It's going to be a vertical compression of your parent function. H comma k is going to be your vertex, where h is going to determine the horizontal translation. That's going to tell you how far right or left you are going to move your parent function. Since it's x minus h in here, if you have x minus 3, it's going to move to the right 3. If you have x plus 3, that means your h is actually -3, which means you're moving the parent function to the left 3. So be aware of that. It's the opposite of whatever you see. Here, it's exactly what you see. K is going to be the y value of your vertex, and it's going to determine your vertical translation of your parent function. If this is plus 2 at the end, then it's going to tell you that you're going to take your parent function and move it up 2. It's a vertical translation up 2. Remember, translation is just a shift. So here's what each of those specific constants are going to do to your parent function. Now let's try graphing. So it says how to graph an absolute value function. We have y is equal to 2 times the absolute value of x minus 3 plus 1. First thing we want to do is make sure that it's in vertex form. Yes, it is. Now we're ready to go. So let's do this. First, we're going to plot our vertex, h comma k. Again, h is the opposite of whatever you see. So since you see x minus 3, your h is actually positive 3. Whereas k is going to be exactly what you see. So since we see a plus 1, your k value is positive 1. So our h comma k in this case would be positive 3, positive 1. So we go over to the graph, we go right 3, up 1, we put a point. Next, we need to determine whether the graph opens up or down. So we just look at our a value. If our a value is positive, our graph opens up. If our a value is negative, our graph opens down. It's a downward facing v. So we look at our a value, it's 2. That's positive. Therefore, we're going to have an upward facing v. Next, we're going to use the slope to finish the graph. So what's our slope? In this case, it's the a value. What's our a value? It's 2. But how do I write that as a fraction, rise over run? Well, 2 is the same thing as just 2 over 1. So we're going to go from our vertex, rise 2, and then run to the right 1, put a point. Rise 2, run to the right 1, put a point. Boom! That is half of our graph. Because remember, absolute value function, it's a v. How do I get the other side of the v? Well, instead of rising 2 and going to the right 1, we're going to rise 2 and go to the left 1, put a point. Rise 2, left 1, put a point. Draw a v through those points, and you're done. Look how easy that was. Now, a lot of these questions will ask for the axis of symmetry, and that is also very easy. It's just the vertical line, x equals whatever your h value is. So in this case, that would be 3. So x equals 3 is the vertical line that cuts this graph in half. That's your axis of symmetry, x equals 3. Next, these questions will also ask, what transformations did we do to the parent function to get to this new given function? So what did we do to the parent function? Well, each of these specific a, h, and k values did something to our parent function so that we have our current function. So here's our parent function. That's what it looks like. Y equals the absolute value of x. What did we do to this function? Well, the a value, since it's bigger than 1, we had a vertical stretch by a factor of 2. That's what we talked about in the previous slide. That makes sense, right? If you look at your parent function, our new given function looks like we took the parent function and stretched it upwards. What did our h value do to the parent function? Remember, this is a horizontal translation. It tells you whether the graph shifts left or right. Since it's x minus 3, remember it's the opposite of whatever you see, so we went to the right 3. We took the parent function, moved it to the right 3. That's how we got our new given function over here. And then what did this k value do? It shifted the graph, the parent function, up 1. And yeah, that's why we're here. We shifted to the right 3 and up 1. Boom! These are the transformations that occurred to your parent function to get your new given function.
Which Lord of the Rings characters are the best at giving gifts? The elves! Example time.
Now, example 1 says graph the following absolute value function, find the axis of symmetry, and describe the transformations of the parent function. So here we have y equals the absolute value of x. For those of you who have been paying attention, you know that this actually is the parent function, but we'll get to that later. First, when I have an absolute value function, I want to write it so that I know exactly what my a, h, and k values are. So I'm going to write it out in vertex form. My a value, since I don't see anything here, it's actually equal to 1. If it was equal to 0, then it would just cause the whole thing to equal 0. So that one is actually 1. The other ones, if you don't see your h value or your k value, those are 0. But your a value, if you don't see, that means it's 1. Now I have my a, my h, and my k, so I'm ready to graph. First, what's a vertex? That would be 0, 0, h, k. So I go over to my graph, put a point at the vertex. Next, is this graph going to open up or down? So we look at our a value. If a is positive, we open up. If a is negative, we open down. Since we have a positive 1 as our a value, our graph is going to open up. We're going to have an upward facing v. Next, we're going to use the slope to finish the graph. What's our slope? It's 1. How do I write that as a fraction? 1 over 1. Now that we have that, we go over to our vertex. We go up 1, right 1, put a point. Up 1, right 1, put a point. How do we finish the graph? That's only half of it. Well, instead of going up 1, right 1, we go up 1, left 1, put a point. Up 1, left 1, put a point. And we know to do that because, remember, it opens up. It's an upward facing v. That's what the graph of the absolute value function looks like. So now we make a v going through these points, and you've graphed it. Look how easy that was. Now for the other stuff. Find the axis of symmetry. That's just x equals h. What's our h value? 0. So x equals 0 is your axis of symmetry. That's the vertical line that chops your graph in half. What transformations did we do to the parent function? If you recall, this is the parent function. Because it's the parent function, we didn't do any transformations. We're done.
What's a hobbit's favorite fried food? Onion rings! You try.
Okay, again, we want to write it in vertex form so we know what our a, our h, and our k are. In this case, this negative out front means our a value is actually negative 1. What's our h value? Well, there's nothing in here. That means it's 0. And what's our k value? Well, it's what you see added or subtracted at the end, so that would be positive 4. So now we're ready to graph. We're going to plot our vertex. What's our vertex? H, k. 0, 4. We go over 0 on our x-axis, up 4 on our y-axis, put a point. Next, is our graph going to open up or down? Well, look at our a value. If our a value is positive, it opens up. If our a value is negative, it opens down. We have a negative a value, which means our graph is going to open down. So we're going to have a downward facing v. Next, we're going to use the slope to finish the graph. So what's our slope? Our slope is our a value, which is negative 1. How do I write that as a fraction, rise over run? Well, it's going to be -1 over 1. Please don't put -1 over -1. That's obviously +1, right? Because if you divide a negative by a negative, it makes it positive. So here, -1 is the same thing as -1 over 1. So now we use this slope to graph the rest of the line. We go to our starting point, our vertex. We go down 1 because the rise is -1, and right 1, put a point. Down 1, right 1, put a point. Now that's half of the graph. How do we get the other half? Well, the graph opens downward. It's a downward facing V. So we're going to go back to our vertex, and we're going to go down 1, left 1, put a point. Down 1, left 1, put a point. Draw a V through those points, and you have successfully graphed your absolute value function. Next, find the axis symmetry. X equals h. What's h? That would be 0. So our axis symmetry is x equals 0. That's the equation of the vertical line that chops your graph in half. Next, what are the transformations of the parent function? We need to look at our a, our h, and our k, and they'll tell us exactly what happened to our parent function to get this original function. First, remember, if your a is negative, it's a reflection over the x-axis. And that makes sense, right? If your parent function opens up, you had to reflect it over the x-axis so that it opens down now. So the first transformation is that we reflected it over the x-axis. This h, well, it's 0, so that didn't do anything. We didn't shift it to the left or right any, and that's why the vertex of our parent function and the vertex of our new function have the same x value. We didn't shift it to the left or right at all, but we did shift it up. We shifted it up 4. So that's why there is a vertical translation up 4. So again, we took our parent function, we flipped it over the x-axis, and then we shifted it up 4. That's how we got our new absolute value function. Okay, example 2, we're doing the same thing. Remember, first thing you have to do is put it in vertex form. Y equals a times the absolute value x minus h plus k. Well, that means we got to get y by itself. How do we get y by itself? We're going to get rid of this -2. To do that, we do the opposite, the inverse. We add 2 to both sides. These are going to cancel each other out. And over here, please do not add these together. This is inside the absolute value. This is not. So what we're going to do is we're just going to take this +2 and tack it on the end. So it's going to look like this. Now, we look like we're in vertex form. So we're going to write it out so we know what our a, our h, and our k are. So it's going to be y equals, our a value is going to be this invisible 1 out front. Our h value, since it's x minus h, how did we get this to be plus? What did our h have to be? That means our h had to be -5. And then our k value is just exactly what you see out here. Perfect. We are in vertex form. We know what our a, our h, and our k are, so we're ready to graph. First, we plot the vertex, h comma k. In this case, that would be -5 comma 2. Go over to the graph, go over to the left -5, up +2, put a point. Next, determine whether the graph opens up or down. So do we have a positive a value or a negative a value? Our a value is 1, therefore it's positive, therefore we're going to have an upward facing v. Next, use the slope to graph the rest of the line. What's our slope? Our slope's our a value, which is, in this case, 1, which we write as a fraction, 1 over 1. So we go to our vertex, we go up 1, right 1, put a point. Up 1, right 1, put a point. Now since it's an upward facing v, we have to go back to our vertex and go up 1, left 1, put a point. Up 1, left 1, put a point. Now we draw a v going through those points. We have graphed our absolute value function. Sweet. Next, we need to determine what is our axis of symmetry. Well, it's just the vertical line x is equal to h. So what's our h? -5. So our axis of symmetry is x is equal to -5. It's that vertical line. So we go over here. X is equal to -5. It's the vertical line that chops our graph in half. And you're done. Lastly, transformations to the parent function. Let's look at our parent function. What did we do to this in order to get this? Let's look at our a, our h, and our k. Our a value, what did that do to the graph? Nothing, it's 1. What did our h value do? Well, remember, that controls horizontal translations, left and right. Since it's -5, that means we took the parent function and moved it to the left 5. Now, what about the k value? Well, the k value controls vertical translations. So since it's +2, it took the parent function and moved it up 2. So with these two translations, we have a horizontal translation to the left 5, and then a vertical translation up 2. And you can see, yeah, if we shift this parent function to the left 5 and up 2, we get our current graph.
What do you call it when Gimli only drinks milk? Low fat! You try.
Okay, so again, first thing we want to do is put it into vertex form. So it's got to be y equals a times the absolute value of x minus h plus k. So I want to get this +4 to the other side. So to do that, I do the opposite, the inverse. I subtract 4 from both sides. That way these cancel each other out. And over here, remember, we're subtracting it from the end. We're not subtracting it from what's inside the absolute value. So it's going to be y is equal to -3 times the absolute value of x plus 2 minus 1. Now again, this is technically in vertex form, but I want to readily readily see what my A, H, and K are. I can see my A is going to be -3, but in here it's x plus 2. Remember, your H value is not going to be positive 2 because this is supposed to be x minus H. So in order to be x plus 2, that means your H value would have had to have been -2. So we have it now in vertex form and we're ready to graph. First, plot the vertex, h comma k. So what's our h? We said it's -2. What's our k? We said it's -1. So we go over to the graph, we go over to the left -2, and then we go down -1 on our y-axis, we put a point. Next, we decide, is the graph opening up or down? Do we have a positive or negative a value? Well, our a value is -3. Therefore, we have a negative a value, so our graph is going to open down, meaning from this vertex, we're going to have a downward facing v. From here, we're going to use the slope to graph the rest of our v. Now, what is the slope? The slope, again, is your a value. What's your a value here? It's -3. So our slope, then, is going to be -3. But how do I write that as a fraction, rise over run? Well, -3 is the same as -3 over 1. Please don't write -3 over -1. That's not the same thing. That's +3. So what we want to do here is we're going to take this slope to graph the rest of the line. So we go from our point, our vertex, and we go down 3, right 1, put a point. And we go down 1, 2, 3 to the right 1, put a point. That's half of our v. How do we get the other half? We go back to our vertex, and since it's a downward facing v, we know it's going to be over here. So we go down 3 and to the left 1, down 3 and to the left 1. We then draw a v through those points, and you have successfully graphed your absolute value function. Next, axis of symmetry, because it asks for it. What is that? That's x is equal to h. What's our h value? -2. So x equals -2 is your axis of symmetry. Again, that's the vertical line that cuts your graph in half. Next, what are the transformations of the parent function? Again, the parent function, y is equal to the absolute value of x. That's what it looks like. Now, how did we go from here and get our red graph here? Again, we look at our a value, our h value, and our k value. What does the a value tell us? Well, since it's negative, it's a reflection over the x-axis, so it's going to flip the graph upside down. That's what the negative means. What does the 3 mean? Well, since you have an a value that is less than -1, we have a vertical stretch by a factor of 3. Next, what does the h value tell us? Well, remember, the h value is the horizontal translation, so it tells us that we move to the left 2. And then what does the k value tell us? Well, this is our vertical translation, and this tells us that we move down 1. So again, the negative a value flips the graph. The 3 makes it stretch, so it's thinner. The h value moves it to the left 2, and the k value moves it down 1. Example 3, doing the exact same thing. Again, we want to put it into vertex form so we know what our a, our h, and our k are. Our a value is -2/3. Our h value is going to be 4. What is our k value? There's nothing out here. That means it's 0. So now we have all 3 of those. We are ready to graph. First, plot our vertex. What's our vertex? H comma k. That would be 4 comma 0. We go over to our graph. We go over 4, up or down 0, put a point. Next, determine whether the graph opens up or down. Look at our a value. Is it positive or negative? Our a value is negative. Because our a value is negative, we're going to have a downward facing v. So our graph is going to open downward. Next, we have to use the slope to graph the rest of the line. So what's our slope? Our slope is -2/3. And because it's already a fraction, that makes it easy. Our rise over run is -2/3. Again, this negative sign could go with the numerator or denominator, not with both. So we put the negative, I usually put it with the numerator. That's why it's -2/3. Now, we use that slope to graph the rest of our v. So from our vertex, we go down 1, 2, and over 1, 2, 3, put a point. Down 1, 2, over 1, 2, 3, put a point. Now, since it's a downward facing v, we go back to our vertex and we got to get the rest of our graph, the other half. So we go down 2 and to the left, 1, 2, 3, put a point. Down 2 and to the left, 1, 2, 3, put a point. Now we draw a line going through our points right here and we get a v. Perfect. We have graphed our absolute value function up here. Next, what's our axis of symmetry? Axis of symmetry is x is equal to h. What's our h value? We said it's 4. So x equals 4 is your axis of symmetry. So we go over, put a vertical line at x is equal to 4. Again, that's the vertical line that cuts your graph in half. Last but not least, what are the transformations of the parent function? So here's our parent function. How do we get from here to here? How do we get from this purple v to this red v? First, we look at our a value. It's negative, which means we have a reflection over the x-axis. Next, because our a value is between -1 and 1, it's a fraction like this. So what we know is that it's a vertical compression, which means it flattens out the graph. It doesn't stretch it like it did before. It makes it flatter, wider. So that's a vertical compression by a factor of 2/3. And then our h value, since it's x minus 4, that means h is 4, which means we shift the graph to the right, +4. So we had a reflection over the x-axis, a vertical compression by a factor of 2/3, and then a horizontal translation to the right, 4.
Why couldn't Gandalf ever stop smoking his pipe? Because he had a bad habit. You try.
Same thing. First, put it into vertex form where we know what our A, our H, and our K are. So here our A is 1/4. Our H, there's nothing inside of the absolute value added or subtracted, so we know that's 0. And then this -7 is going to be our K value. Sweet. Let's plot our vertex. Our vertex is H comma K, which means it's going to be 0 comma -7. So we go over 0 on our x-axis, down -7. On our y-axis, put a point. Got our vertex. Next, determine whether the graph opens up or down. Is it a positive or negative A value? A value is 1/4. That's positive, so our graph is going to open up. Our V is going to be up. Next, use a slope to graph the rest of the line. What's our slope? Our slope's our A value, which is 1/4. So we rise 1 and we run 4. So from our point, we're going to go up 1 to the right, 1, 2, 3, 4, and put a point. Next, we're going to go up 1 over 1, 2, 3, 4, put a point. Sweet, that's half of our V, so we come back to our vertex, and instead of going up and to the right 4, we go up 1 and to the left 4, and we put a point. Next, we go up 1 and go to the left, 1, 2, 3, 4, and put a point. Now draw a V going through those points. We have successfully graphed our absolute value function up here. Next, what is our axis symmetry? That's the line x is equal to h. What's our h value? That's 0. So x is equal to 0 is our axis of symmetry. That's the vertical line that cuts our graph in half. Next, what's the transformations of the parent function? So this is our parent function here. How did we go from this purple function right here to this red function right here? Well, we look at our A, our H, and our K. What did our A value do? Well, since it's between -1 and 1, it's a fraction. What we can say is that it's a vertical compression by a factor of 1/4. It compressed the graph. It flattened it out. That's because our A value is 1/4. Our H value is 0. That means we didn't shift to the left or right any, and you could tell because look at that. We're on the same X value. And then we had a vertical translation down 7 units. That's our K value, right? Our K value controls that, and we shifted down 7 units. Boom, that's how we got there. A word problem says 2 students are about to brawl over a question on their absolute value group quiz. John believes that the absolute value function y is equal to the absolute value of x plus 8 minus 3 involves translating the parent function y is equal to the absolute value of x to the right 8 units and down 3 units. Alexis wants to hit John because she thinks this function involves translating the parent function to the left 8 units and down 3 units. Determine who is correct and prevent a fight from breaking out. So all we have to do is graph this guy right here and the parent function and determine, did we shift the parent function to the left or to the right? So here's our graph. Here's our parent function. Y is equal to the absolute value of x. Now, we take our absolute value function right here that we're trying to figure out whether it's shifted to the left or the right. And we want to figure out what is our A, what's our H, and what's our K. So I'm going to rewrite this absolute value function, even though it's already in vertex form. I'm going to rewrite it so I know what my A, my H, and my K are. My A is this invisible 1 out front. In here, this is supposed to be x minus h. Because there's a plus here, that means your h had to be negative. So this actually means that our h value is -8, and our k value you can see is still -3. Now let's graph this. First, plot the vertex. What's our vertex? H comma k. That's -8 comma -3. So we go over to the left -8 and down -3, put a point. Now technically we could stop right here because we already know that we're shifting to the left 8, but let's not. Let's keep going. Do we open upward or downward? Well, since our a value is positive, that means our graph is going to open up, and now we use our slope to get the rest of the line. So what's our slope? It's 1. And if we were to write that as a fraction, so we know our rise over run, that's 1 over 1. That means from our point, our vertex, we go up 1, right 1, put a point. Up 1, right 1, put a point. We go back to our vertex because it's supposed to be a V, and we go up 1, left 1, put a point. Up 1, left 1, put a point. Draw a V through those points, and you can see that our parent function is translated to the left 8 units and down 3 units. Because of this, we know that Alexis is correct.